So this we will solve another question by again. And the problem will be of maximization time. So let's start the second problem on begin. Start to solve problem. Right? So let's say that the problem is maximize. That is 2x, 3x, 4x. This is our objective to the maximization time. And objective to first we have to 3x1 plus x2 plus 4x2 600. Second one 2x4 4x plus 2x3 again 4x. The third one is 2x1 2x2 plus 3x2 equal to 5. Right? So these are the three constraint equations, and then we have the non-negative constraint equation x1, x2, x3 greater than equal to 0. Okay, now let's solve it by beginning. Since the problem is of maximum, we'll convert it to standard form. So this slack and the artificial will be added to the objective. Write down the initial equation, then we go with the constraint. The first equation 3x1 plus x plus 4x. Since the inequality is less than equal to, so we just need to add this slack variable. We add s1, that is equal to 600. Or add 0 s1 over. That's fine. Now, second equation is 2x1 plus 4x2 plus 2x3. It is greater than equal to. So we have to subtract the surplus variable. So we subtract s2. So I add 0 s2 over here to the objective function such that it makes no change in the objective. Right? And we write 0 s1 we can write over here, and then we have minus s2. And in order to make it in order to get the initial basic feasible solution, we will have to add up the artificial variable over here. So we add a1, that is equal to 480. So I have to add. Now see, because it is a problem of maximization type, so we have to assign a penalty of minus m. So here it will come as minus m a1. So the penalty is of minus m, right? Where m is the penalty, which is very, very large. So we have 480, and then we have the third equation, 2x2 plus 3x2 plus 3x3 plus a2, right? Is equal to 5. So this is, we have sorry. So the constraint equation. Now the basic variables are, we have x1, we have x2, we have x3, we have s1, we have s2, we have a1, and we have a2. That is equal to, sorry, greater than equal. They are all have positive minus a. That is the objective function. Now we convert into the matrix form standard. So we have 3, 1, 4, 1, 0, 0, 0. So we have 1, x2, x3, s1, s2, A1 and A2. These are the variables. We have value of the solution, which is 600, 480. So the second equation comes out to be 2, 4, 2, 0, minus 1, 1, 0. Third one is 2, 3, 3, 0, 0, 0, 1. So now we have the identity matrix with 1, 1, 1 as the diagonal and the next value is 0. So we have what it takes to have the initial variable. So, right? I'll draw the table in the next. Okay, so let's create table. Table is that the first column is always a variable. PV for that. First column. After that we have CV and then XP. We have X2, X3, X1, X2, A1, and we have XP by XJ. Ratio. And then we have a for the iteration. Let's do that with one. Okay, so that is so initially the basic variables we are forming the identity matrix are S1, then we have A1, then we have S1, we have A1, we have A2. These are coefficient of S we have 0. Now A we have minus M and A2 we have minus again. Solution is we have 600, we have 480 and we have 540. Okay. And we copy down the entire table as it is. So we have 3, 1, 4, 0. Then we have 2, 4, 2, 0, minus 1, 1, and 0. In the last one is we have 2, 3, 3, 0, 0, 0, and 1, right? Now, let's take the Z at the first instance will be 480 plus 540. That will be 1020. We have 1020, and that is what we have. So, and it will be with minus. And we have ZJ. Now, M is a very big number, right? We won't have it. So, that is the first thing that we have the initial variable. So, start. So, we have minus 2M and minus 2M. We have minus 4M over here. Okay. We have to write the CJs as well over here. That's 2, 3, 4, 0, 0, minus 10 CJs. So, minus 4M. We have 4 and 3 minus 7M, and we have minus 5M. We have a 0, and we have a positive M over here, and we have a minus M and minus M. And we have the condition of optimality CJ minus ZJ. So this is 2 minus 4M, so 2 plus 4M. Right? Then we have 3 plus 7M. We have 4 plus 5. This remains 0. Just minus 1. So 0 and now that means we have to select. Now because it is a case of maximization, so the iteration will be same than that of a system of maximization, right? So we have an optimal solution, so all the values are negative or zero, right? And we select the most positive value. So the one having the highest value with m. So 7m is max, right? So we select this. That means x2 will move in. It's the entering variable, but somebody has to move out. So let's see. So we have 600 by 1, that is 600. We have 480 by 4, so that is 120, I guess. Right? And then we have 540 by 3. The 5, that is 1, 2, 2, 180, 540 by 3. So, yeah. So that is 180 I have. So the leading variable is a1. So a1 will move out. Now because a1 is an artificial variable, that will be removed from the table. We won't tabulate for a1 further on. So this one, this column will be eliminated. Right? So we can remove one of the values. So now let's go with the iteration. So we have a first iteration and we have s1. Instead of a1, we will have x2. X2 enters the table. We have x2 now, and we have a2. Right, so that is what the table looks up arrow. Now x2, the key element is 4, and we have to make this as 1, and all the other elements of the column have to be 0. So 1 and 3 have to be weighted. So in order to make 4 1, we have to do R2 tends to R2 divided by 4. 480 by 3. So the coefficient of x2 is 3. We write down 3. And then okay, 480 by 4. So we have 120. Then 2 by 4 is 1 by 2. 4 becomes 1. Then again 2 by 4 is 1 by 2, 0. Then we have minus 1 by 4. And a2, a1 is removed. So we have only a2 and a2 is right. So that was it. Okay. Now let's come to the third one. It's the first one. First one is 1 and we need to make 1 and 0. So we have R1 tends to R1 minus R2. It's simple. We have with a new row. Okay. So 600 minus 120 is 480. So what we get is we get a 480 and the coefficient is 0. Minus. Now 3 minus 1 by 2. 3 minus 1 by 2 is 5. Yeah, 5 by 2. 1 minus 1 is 0. 4 minus 1 by 2 is 8 minus 7 by 2. So this is 7 by 2. 1 minus 0 is 1. 0 minus 1 by 4, that is 1 by 4, positive value. Then we have last 0 minus 0, that is 0. That's the A2. Okay, let's come to the third row now. In third row, we have a 3. So R3 tends to R3 minus 3 times R2. We have to make 3 first and then we have to subtract. So 540 minus 360. Okay. So we have just so we have 540 minus 360, 180. So we have a value 1. Then we have 2 minus 3 by 2. So 2 minus 3 by 2 is 1 by 2 2 3 by 2, 1 by 2, 1 by 2, then 3 minus 3 is 0. 3 minus 3 by 2, 3 by 2, then we have a 0, then we have 3 by 4 in the dimension. So that is the value. Let's calculate Z. Z is 360 minus 180 m. Okay, let's calculate ZJ. So what do we have? We have 3 by 2 minus m by 2. So I have 3 by 2 minus m by 2. That is Z. Over here we have only 3. Over here we have 3 by 2, 3 by 2 plus, sorry, plus minus 3m by 2. This is minus 3m by 2. This is minus. And over here we have a 0. Then here we have minus 3 by 4 minus 3m by 4. And here we have minus m. So let's see again Cj minus Zj, condition of optimality. If all the values are negative or 0, that we have a degree of optimality. Otherwise, we have to go with the equation. So 2 minus this value. So 2 minus this is 2 minus 2 minus 3 by 2 plus m by 2. So that is 4 minus 3. 1 by 2 plus m by 2. This is 1 by 2 plus m by 2. So m is positive, that means we have to go with the equation as of now. And let's see what the other value is. 3 minus 3 is 0. That is the first, this is the second value. Now here we have 4 minus 3 by 2 plus 3m by 2. So this is 8 minus 3. So this is 5 by 2 plus 3m by 2. Okay. This is 5 by 2 plus 3m by 2. So this will remain 0. This will be positive. 0 plus 3m by 4. Is 0. So over here the positive value, this is 1.5. So this is the maximum value that we have. ये हो गया 0.75, ये हो गया 0.5, this is 1.2. So this is a value. So select this. That means x3 will move in and somebody will move in. So 480 by 7 by 2. ये हो जाएगा आपका 480 by 7. 137 point something है, so I'll write 138 approximately. ये आ जाता है 240. Okay. लास्ट वाली वैल्यू हो जाती है 4/3, तो 60 into 4, sorry, 60 into 2, 120. Right? So this is the least value. That means that this is the key variable. So A2 will move out. That means another artificial variable is moving out. So we don't have to. We will remove one more column A2. That will be removed. So the basic variables now are, we have S1, we have X2, and we have, instead of A2 now we will have X3. So we have X3. Now the coefficients are 0, X2 का coefficient है 3 and X3 का coefficient है 4. Now this is 3/2, so 3/2 needs to be made. So R3 tends to R3 multiplied by 2/3 या divide 3/2. So इसको multiply कर दीजिए तो 180 into 2/3, तो ये 120 हो जाता है, 120. तो 2/3 करते तो ये 1/3 बच जाता है. तो आई एम लेफ्ट 1/3. 0 है तो 0 हो जाता है, ये 1 हो जाता है, ये 0 हो जाता है, और ये 3/4, तो 2/3 है, 3 1/2 बच. 1/2, that is the only value. So now we are left with the x1, x1, x2, x3, and s1 and s2. Both the artificial variables are out of the table. Okay. Now let's come to the first row. First row we have 7/2. With 7/2 को हमें 0 करना. So r1 tends to r1 minus 7/2 r3. वो करना है. तो देखते हैं. तो 480 minus, तो यार क्या है, we have 480 minus 7/2 into 120. 60 हो जाएगा, और ये 480 minus 420 यानी 60 बच जाएगा. We are left with 60. Then we have 5/2. So we have 5/2 minus 7/2 of 1/3. ठीक है. देखो ये हो जाएगा 5 minus 6 हो गया 3. 15 minus 7/6 कितना हो गया 8/6. 4/3. 4/3 हो जाता है, 0 ही रहेगा, ये भी 0 हो जाएगा, 1 minus 1 रहेगा, और नेक्स्ट है 1/4 minus 7/2 of 1/2. 1 minus 7 minus 3/2. ठीक है, तो ये हो जाएगा -3/2. ठीक है, नेक्स्ट पे आते हैं, सेकंड वाले पे. R2 tends to 1/2 है, तो R2 tends to R2 minus 1/2 of R3. कितना हो जाएगा देखिए, तो 120 minus 1/2 of 120 60. राइट. फिर से आते हैं, 1/2 minus 1/2 of 1/6 हो जाएगा, तो ये हो जाएगा 1/2 minus 1/2 into 1/3 आ जाएगा. 1 रहेगा, 0 हो जाएगा, 0 हो जाएगा, तो ये हो जाएगा -1/4 minus 1/2 2/2 plus 1/4 minus 1/2. That is our value. Now let's see z. Z हो गया 180 plus 480 plus 480 660. ZJ देखते हैं, देखिए तो 0 है तो ये 3 into 1/3, 3/3, 1 plus 4/3, 7/3, ये हो जाएगा 3, ये हो जाएगा 4, 0 हो जाएगा 1/2, CJ minus ZJ, all negative or 0, we are done. So 2 minus 7/3, 2 minus 7/3, minus 1/3, 0, 0, 0, minus 1/3. So condition of optimality is there. So maximum Z is equal to 660 at x1 is equal to 0, x2 is equal to 60, and x3 is equal to 120. So that is the solution. Yeah. So that is how we get the solution for big M. Okay. So the only thing that we need to remember in big M is that we have to iterate for a maximization problem. That is same with the case of simplex. But for a minimization problem, uh, this condition of CJ minus ZJ changes. It is all positive and 0 for the minimization case. Okay, whereas it remains the same for the maximization case. Okay, so that will be all for today. Thank you.